Hey everyone, welcome back to The Doctor is In, the Controlled Environment Agriculture podcast, where we focus on optimizing the indoor plant environment for crops growing in greenhouses, indoor farms, vertical farms, plant factories, containers, and any other facility where we want to grow plants anytime and anywhere. I'm your host, Dr. Nadia Sabeh, president of Dr. Greenhouse. It's so great to have you here today. For those of you who have been listening in, the last couple of episodes, I focused on greenhouses, sort of spurred by my recent visit to the National Greenhouse Manufacturers Association, where I talked about the energy code and sort of what's coming in relation to controlled environment agriculture / controlled environment horticulture. So today I figured I'd continue talking a little bit about greenhouses. Feels like the right time, right? It's spring. Everybody's getting ready for their summer crops. And so I figured I'd just stick with it. And, I recently wrote an article for Greenhouse Grower, which some of you may have seen, called 6 Greenhouse HVAC Trends to Watch in 2023. If you're interested in hearing more or expanding on some of what I'm going to talk about today, I encourage you to check out that article that was published earlier in April. So, I just thought I would, I was kind of thinking about, well, what am I most interested sort of in watching proliferate and develop within greenhouses, and how might it change the nature of business and operations when it comes to managing our greenhouse climate. So I'm just going to talk about 3 that I'm personally very interested in watching here for the podcast today. So number 1 is glazing. For those of you who have listened to the other series or have ever heard me talk, I always say start with the envelope, right? Whether you're an indoor farm or you're in a greenhouse, the glazing, the envelope, the cover has a lot to do with how heat and moisture is transferred in and out of our indoor plant environment. And, there just hasn't been a lot of development in greenhouses in the last 40 or 50 years that have really stuck. I think maybe one of the latest, biggest developments was the, determination that having double layer polyethylene film has a much better insulative value than single layer polyethylene film. And so we've seen sort of this proliferation of double glazing, in some cases triple glazing, but mostly double glazing, whether that's double inflated poly or twin wall polycarbonate or acrylic. We're really seeing that more and more often in our greenhouses because it provides a little bit of resistance to heat leaving the greenhouse in the winter. It's not so effective in the summer because solar radiation is still coming in and we still want to transmit that light to plants. And so, beyond that, there just hasn't been a lot. Maybe there's some different chemical additives that are included to, prevent our plastic from breaking down in UV light. And yes, we have some coatings, to help reduce light transmission in the summer for cooling. But when it comes to the bones, right, of the glazing and the actual structure and materials of the glazing, there hasn't been a ton of development. There's been a lot of talk, but I haven't seen a lot of application yet. And so, some of the interesting glazings that I'm starting to see come out and be promoted and at least researched at the various universities who have CEA programs are different glazing styles. So I'm seeing more spectrum blocking, spectrum modifying, electricity producing glazings, right? So these are really interesting. So a spectrum blocking glazing means that it might block near infrared wavelengths from coming in, which effectively helps to keep your greenhouse more cool, because then we're selecting for a spectrum of, say, PAR or of certain wavelengths that is good for plants, but blocking out, the extra light that we don't really need to grow plants and that just heat up the greenhouse. this is going to be a really effective style of glazing, in hot, sunny locations in the Sun Belt of the US, where cooling is more of a predominant HVAC need than, say, heating. So I'm curious to see how that pans out. Another type is the spectrum modifying glazing, which can help to shift high energy UV and blue wavelength light into lower energy yellow and red wavelengths, which are more photosynthetically active and available for plants. So now, we have one that's blocking the heat waves, and this one is converting the UV rays into something that's usable for plants. So that's also very interesting, and I imagine could work in many different locations. We've heard a lot about electricity producing glazings that have, little solar panels or PV cells that are embedded and planted into different glazings. I think a lot of people were really curious about this technology and idea 10 or 15 years ago. Again, I haven't really seen it get out into the industry more. I'm not sure if it's a cost thing, if it's a prove the performance improvement type of issue, but they're still out there, and I know there's still interest, and I'm curious to see if that makes its way into greenhouse designs. And then, just again, double layer anything. In California, we just, have a new energy code that went into effect January 1st of 2023, and it is requiring that all new greenhouses have double layer glazing. So that can be double film polyethylene, twin wall polycarbonate, twin wall acrylic, double pane glass. If anyone has the pocketbooks to pay for such a high cost glazing. But, California is at least nudging us in that direction to improve on some energy savings. If you want to hear more on my thoughts on that, listen to my podcast from last week where I talk about the energy efficiency, or I'm sorry, and ways to cool the greenhouse. Okay, so the second technology and development in greenhouse design that we're seeing more of, and that I think we will continue to see more of, are hybrid greenhouses. The hybrid greenhouse is characterized usually by positive pressure, so we're pushing air into the greenhouse as opposed to pulling it into the greenhouse. Usually there's a mix of outside and greenhouse air that is used to condition the greenhouse. So it's kind of like an air side economizer that we would use in a commercial building or in an indoor plant environment in a warehouse. Basically, there's a front chamber where the program, the control system would decide, okay, we'd need this much cooling or this much heating. So we're going to recirculate some air from the greenhouse to conserve energy, and then we're going to bring some outside air into the greenhouse to assist with cooling or dehumidification or possibly heating. And so this mixture, or this air, these two air streams mix together in this front chamber. And that chamber could also have heaters, have unit heaters, or have hot water coils, chilled water coils. You might see an evaporative cooling pad on the wall. And so you have all this air conditioning that occurs within this chamber, and it gets well mixed, and then fans push that mixture of air into the greenhouse to heat or cool it. A lot of times that air is pushed into the greenhouse through ducts or polytubes that are sitting under benches, under tables, and sometimes also overhead. There are challenges with the hybrid greenhouse. One, it's a lot of infrastructure to build into the greenhouse to get really pretty good control if everything is sized correctly. I want to add that. Definitely heard that, some greenhouse growers don't have enough cooling or don't have enough heating built into the system because maybe some calculations were off, or, the designer didn't understand the location. But other than that, we're really pushing conditioned air into the entire greenhouse and delivering it from end to end if we have the polytubes built into that system. But it does take a certain level of sophistication of controls to be able to monitor what's happening inside the greenhouse, what the weather is like outside the greenhouse, to then operate various dampers and systems in concert with each other to deliver the perfect mixture of air into the greenhouse. The other thing that I want to, emphasize is that I've been in some of these hybrid greenhouses, and there was no source of relief for the air that we're pushing into the greenhouse from the outside. And so sometimes if you ever come to a greenhouse and you see it kind of bowing outward, that glazing is kind of, looks like it's ballooning out, it probably means that they have a positive pressure system without enough relief ventilation. And that relief can happen in the ridge vents or in the walls, or even with some backdraft dampers. It could be very simple. Okay, so the third trend or advancement that I'm really curious to watch to see if it actually does take a footing here in the US is heat pumps. Heat pumps can be used both for heating and cooling. And heat pumps are really unique because rather than generating a source of heat from using a flame to run a boiler or in a unit heater, what a heat pump does, it just moves heat around that's already available. It is literally pumping heat from one location to another location. And that's why we can use it for both heating and cooling. So if it's winter and we want to heat the greenhouse, an air source heat pump, what it would do is it would pull heat from outside. And I know that seems kind of silly because it's probably colder outside than what you want it in the greenhouse, but there's always heat available in nature and in the air. And so it can extract that heat that's in the air, even if it's, 20 degrees Fahrenheit, and push that heat into the greenhouse that might be 65 degrees Fahrenheit. And then you can reverse that heat pump in the summer where it could be 100 degrees Fahrenheit outside in the summer and you want it to be 80 degrees in the greenhouse. As solar radiation and heat, convective heat is being added to that greenhouse, then that heat pump can extract that heat from the greenhouse air and push it to the outside air. So heat pumps are not generating any heat. They're just moving heat and energy around. It's kind of cool. And there's three sources or three types of heat pumps. There's the air source heat pump. So it's moving air, hot, heat from the air to another source of air, another body of air. Then we have water source heat pumps. So in that case, we're using water as the sink or source of heat. So if you want to cool your greenhouse in the summer, then your heat pump would extract heat from the air and then dump that heat to a body of water. And then we have ground source heat pumps where we are extracting or pushing heat into or out of the ground. And some people call this also geothermal heat pumps. And we've had a lot of questions about ground source heat pumps. On paper and in theory, they seem like they would work really well. They would have a low impact on the environment. If you are somewhere where you have a lot of land and acreage, then that seems like it could work really well. There is a big challenge with ground source heat pumps, and that is balance of load. And I bring this up because a lot of times we have a greenhouse or an indoor facility where we primarily need to heat that greenhouse. Or for an indoor facility, we want to primarily cool and dehumidify that indoor plant environment. And so if I just stick with a greenhouse, if we want to heat that greenhouse, then we are extracting heat from the ground, right? So we have these boreholes that we've dug into the ground, and we're going to pull heat from the ground, right? And a lot of people say, oh, well, the ground is always the same temperature, so it's going to be this constant source of heat. Well, that's true if we're not extracting heat from it. But as soon as we start extracting that heat to heat the greenhouse, we are depleting, right, the battery, that source of heat that we're relying on to heat the greenhouse. So if we're just in a cold environment and all we're doing is extracting heat and dumping it into the greenhouse, eventually we're going to lose that heat, right? The temperature of the ground is going to drop below to a temperature that is going to make a ground source heat pump very effective or efficient. But if we're in a location where we need a pretty equal balance of heating in the winter and cooling in the summer, then what we can do is in the summer months, now we're extracting heat from the greenhouse and dumping it back into the ground, right? And recharging that battery, so to speak. And so as long as there's a balance of heating and cooling, whether it's seasonal or whether it's, diurnal during the day, that's when a ground source heat pump is going to be most effective. But, the amount of heat, the amount of ground and boreholes that you're going to need in order to heat and cool this greenhouse is going to be pretty enormous. If we think that, putting solar panels, a solar array requires a lot of acreage to power a greenhouse, think in terms of the same scale when it comes to ground source heat pumps. The reason I want to watch these heat pumps and this technology kind of infiltrate into greenhouses and indoor agriculture in general is that there is a lot of energy savings potential. The Department of Energy here in the U.S. Predicts, anywhere from a 30 to 60% energy reduction in homes and in other buildings where they are applied. And, again, would we get the same energy savings and payback for a greenhouse or an indoor farm? I'm not 100% sure. It's going to depend on if it's air source, water source, or ground source heat pump. It's going to depend on your location, of course. But it is interesting as we are reaching for these decarbonization goals and, getting off of the electricity grid or the power grid. If we can reduce our reliance on using combustibles to produce that heat, right? To produce that flame that then heats up the water or heats up the air, then we're moving towards electrification, right? And so, yes, there are questions about the source of power and the electrification, right? If that's very green, that's a different question, and that's outside the site boundary layer or condition. But it is interesting, right, to think of a greenhouse not using boilers and unit heaters. It's kind of mind blowing to me to think about not using natural gas or propane or other fossil fuel to heat a greenhouse. And I'm personally curious to see heat pumps applied to greenhouses here in the US. I know in Europe, they are used, and I'd like to hear about the success of that. If you need any sort of backup heat, whether it's electric power or whether you do have a natural gas line or propane tank on site just in case it gets too cold to run the heat pump effectively. But I do know that Europe and Asia heat pumps are more popular than they are here right now in the US. So those are the sort of the three technologies and trends that I'm paying attention to here in the US for greenhouse designs and operation. The different types of glazings that are becoming available and that we're seeing in R&D, the hybrid greenhouse, and the improvement on controllability of the environment through that mixture of inside and outside air and having all the heating and cooling elements at one end of the greenhouse and conditioning that air before it's delivered to the plants. I'm curious to see if that continues to proliferate in the industry. And the third one is heat pump heating and cooling, and to see, what is the appetite for moving away from combustion based heat sources and moving towards electric driven heat pumps. Very curious to see how that plays out. Okay, so again, thank you for tuning in and listening to this series on greenhouses. I hope you enjoyed it. You can check out our blog or my blog. I talk a lot about greenhouses in there. Again, the 6 trends to watch in HVAC for greenhouses was published with Greenhouse Grower in their April issue. You can find it online as well. And, thanks for tuning in. If you have any questions or comments, please send them my way. I would love to hear from you and chat more about greenhouses. All right. Have a great day and keep on growing.